Hello, hi everyone. Welcome to the Student the Brand. This is Vasudha sir. Today we are going to discuss about electric current. Electric current is nothing but rate of flow of charge. I equal to Q by T. Electric current. Electric current. Electric current is nothing but rate of flow of charge. Rate of flow of charge. I equal to Q by T. I equal to Q by T. So rate of flow of charge. Flow of charge through unit cross section area per second is called electric current. SI unit of electric current is known as ampere. SI unit of electric current is known as ampere. SI unit of current is SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. So 1 ampere is defined as 1 ampere is defined as 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb per 1 second. 1 ampere of current is 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. So inside of the conductor there are many charges will move: positive charge, negative charge, positive charge, negative charge, positive, negative, positive, negative. There are many charges will move. So many charges like that. It's not only one or two. So many charges will move. So that's why it is called quantization of charge. Quantization of charge is nothing but Q equal to Ne. So Q equal to plus or minus Ne. Q equal to plus or minus Ne I am taking. Q equal to plus or minus Ne. So why you are taking plus or minus Ne? Q equal to plus or minus Ne is nothing but, so here n is the number of charges. Okay, charges are moving inside of the conductor. So that is that is so plus or minus we are taking, plus or minus either positive charge or negative charge, positive charge or negative charge. So charges are moving inside of the conductor. Charges are moving inside of the conductor. That's why we are considering n. So plus or minus mean plus is positive charge, n so electron is negative charge, proton is positive charge. That's why plus or minus we are taking. Now we are considering on one electron 1.6 into 10 power minus 19 coulomb present. On one electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb 1 by 1.6 into 10 power minus 19. So that is if you are taking in 1 coulomb 1 by 1.6 into 10 by 10, 10 by 10 equal to 10 power 19, 10 power 19. If you are solving this one, so 10 by 16, 10 by 16 into 10 power 19. So if you do this, you'll get 0.625 into 10 power 19. Then you'll get in 1 coulomb, so 6.25 into 10 power 18 electrons are present. 6.25 into 10 power 18 electrons are present. So see in one on one electron 1.6 into 10 power minus 19 coulomb, on one electron 1.6 into 10 power minus 19, on one electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb 6.25 into 10 power 18 electrons are present. In 1 coulomb 6.25 into 10 power 18 electrons are present. Okay, so this is about electric current. Okay, next one we are going to the electrical appliances. We'll discuss about electrical appliances. Those are cell, battery. So electrical appliances, we'll discuss electrical appliances. So electrical appliances are those are, so we'll discuss electrical appliances. First one is cell. First one is cell. Second one is battery. Battery. And third one is open switch. Open switch. Open switch. Closed switch. Closed switch. And fifth one, resistor. Rheostat. Seventh one, ammeter. Voltmeter. Wire joining. Wire crossing. Wire joining and wire crossing. Next one, bulb. So once again, cell. You can see the cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, bulb. Wire joining, wire crossing, bulb. So this is about resistors are electrical appliances. These are electrical appliances. These are the electrical appliances. Electrical appliances. Now, so we'll go to the electrical circuit. electric circuit, electric circuit, a continuous and closed path of a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. So I am taking here, so this is the cell, this is a battery, I am taking this a battery. Okay, so switch. So I am considering here bulb. Okay, so now you can observe here. So current is flowing, current is flowing. So current is flowing from positive terminal to negative terminal. Current is flowing from positive terminal to negative terminal. Okay, so here there are two types we are considering. One is conventional current and electric current. Conventional current, conventional current and electric current. Second one is electric current, electric current. So conventional current is known as flow of positive charges will be considered flow of positive charges. So flow of positive charges is known as conventional current. Flow of electrons is called electric current. Flow of conventional current. So flow of positive charges will be considered the direction of flow of positive charges will be considered direction of conventional current. The direction of flow of electrons will be considered direction of electric current. Here, positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. So positive charges will move from high potential to low potential, whereas the electrons will move from low potential to high potential. So electric conventional current is nothing but a flow of positive charges. Electric current is nothing but flow of electrons. Flow of electrons. So this is about conventional current and electric current. Okay. Next one, potential difference. Potential difference is nothing but work done to bring. So potential difference is nothing but work done to bring unit positive charge. So electrons will move opposite direction of positive charges. If positive charges are moving this side, so electrons will move like this. Okay, so this is the positive charge and negative charge. Okay, so that is about the conventional current and electric current. Now we'll discuss about potential difference. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Potential difference. So I'm considering here, I'm doing some work to bring unit positive charge. So this is a point A and this is a point B. So positive charge and I'm doing some work. We are doing some work to bring unit positive charge. Katyayani Kumari, thank you so much. Kanyaye Kumar. Oh, sorry. Kan Kumar, thank you so much. So okay done. So work done to bring unit positive charge from one point to another point. Work to bring unit positive charge from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from one point to another point within the conductor is called work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So potential 1 volt equal to 1 joule by 1 coulomb. 1 volt is equal to 1 joule by 1 coulomb. 1 volt is equal to 1 joule by 1 coulomb. So potential difference is nothing but work done to bring unit positive charge from one point to another point. So one more work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So that is nothing but 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule by 1 coulomb. Okay, so this is about potential difference. Coming to electrical potential, electrical potential, electrical potential. Electrical potential is nothing but so work done to bring unit positive charge. So I'm taking this. I'm taking the positive charge. Positive charge I'm considering here. So this is a positive charge. I'm taking this a positive charge. So this is infinity. Positive charge is at infinity. So Okay, so this is the required field. This is the required field. We are doing some work to bring. We are doing some work to bring unit pulse charge from infinity to the required field is called electrical potential. So V equal to W by Q. 1 volt equal to 1 joule by 1 coulomb. 1 volt is equal to 1 joule by 1 coulomb. So potential difference and electrical potential. I hope it is very clear. Next one, we are going to one more, that is next. We'll discuss about resistors are connected in series combination. Resistors are, so before that we will discuss about Ohm's law, Ohm's law, Ohm's law, Ohm's law, Ohm's law, Ohm's law, Ohm's law. So Ohm's law is nothing but Shivani Sharma. Thank you so much. So thank you, Shivan Sharma. So Ohm's law is nothing but Vecna. So thank you so much. So thank you so much everyone. Those who are there in super chat. So I don't know how I have to thank. So really thank you so much. I am so I am doing no from past 5 years onwards. I am doing lot of hard work. So you can see the videos in my YouTube channel. There are many videos. I did so much hard work. Even though I'm getting so many comments negative way, but still I'm accepting. I'm taking in a positive manner because from past 5 years, a lot of hard work. So even I couldn't able to sleep also sometimes. I'm doing one one positive thought, that is to help the people in a good way, to help the people in good way. I'm doing lot of hard work. You can see there are many days. You can observe, you can check my videos, you can check my videos. There are a lot of videos, nearly 4,000 videos. I didn't expect anything from anyone. I'm doing my work. I'm doing my work. So like so many videos I uploaded. So many videos I uploaded. Even though I'm getting so many negative comments, still I am accepting, because I'm helping the students to learn in a better way. So I'm teaching in a according to my point of view. I'm teaching. So whether it is helpful to them or not, so they should know. I'm doing my level best to teach in a best possible way, best possible way. So I uploaded so many videos. So if you don't believe that, once go and check the videos. You can check the videos, my videos. If I'm doing anything wrong, you can check once and let me know. So definitely I can understand, because it's not the day today. I'm not wearing only not only today I'm wearing this dress. From long back onwards, from long back onwards, I'm wearing all these costumes to teach the people in a in a better way, in a best way. So in a better way, in a best way, in a better possibility. So how can I do in a best possibility to teach the students? So in that manner, I just went through it. I just went through it. There are lot many videos. There are lot many costumes. It's not about only today costume. It's not about only today costume. Yes, I can understand. So I can agree. I am accepting the comments. So I can understand, because see, people will see in a different perspective. They may think, yeah, I can understand. But so you can observe, there are lot of videos. You can go for shorts and watch. There are hundreds of costumes. So even I couldn't able. So sometimes I didn't even sleep also. So those days. So throughout the night, until, so if I started right from 10 o'clock until 2 o'clock, 3 o'clock, I'll prepare the costumes. I'll prepare the costumes for teaching. So like in that ways, I went through it. So those are very hard days for me. So even I couldn't even expect, I couldn't even do anything, just I went through it. So to teach in a better way, still I'm continuing. So with your support, please support to me. So I'll do in a best possible way to teach. Definitely I'll do it. Definitely I'll do it. So I'll do my level best. I'm not doing anything. I'm doing my work. I'm doing my work. I'm teaching. So I want to tell the students with my teaching itself, with my teaching itself only. So with the teaching only, I will give the answers to you all. So that's enough. Nothing else. I don't want anything to speak. I want to do my work. Okay. So I'll teach in a better, in a best possible way to reach you all. To reach you all. So please support to me. Please support to me. That word I want. I will ask you. Only support. Support. Just I'll go with my work. Definitely. I'll reach your expectations. What you are thinking. What you are asking. So definitely in a best possible way, I will do. So thank you so much for joining and no attending the class and no interacting with me. So whoever there, so whoever watching this live, so I'm very happy for you. I'm very happy for you, and I'm not able to read out the names those who are there. So those who uh, took the chat, super chat. Thank you so much. I'm happy for you all. Okay, so I couldn't able to read out the name. Sorry for that, but definitely I will. Thank you so much. So I'm very grateful to you. Thank you all. So I'll continue the Om Sila. Okay, sorry for that interruption. Shivani, one more. Oh, Shivani Sharma, thank you. So thank you so much. Thank you so much. So I don't know how to thank more than this. I don't have words also to say. Only one word. Only one word. Thank you so much. Thank you so much. So remaining all, please support to me. Please support to me. That's enough. I will do my work. I will do my work. So whatever comes, whatever the hurdles, whatever the struggles will come. So definitely I will do my work. Okay. So with the work only will do. So thank you so much. Please support. That's enough. So coming to the next one. Ohm's law. Ohm's law is nothing but Ohm's law is nothing but Ohm's law is nothing but I am taking here this the battery. Resistor, I am taking this resistor. This is about voltmeter. So I am considering here this the there are four cells. I am taking. There are four cells. I am considering here like this. So current is passing. So here the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to the potential difference across the ends of the metallic conductor. Potential difference across the ends of the metallic conductor is directly proportional to current flowing through it. So the potential difference across the ends of the given metallic conductor, V is directly proportional to I, V equal to IR. So V is directly proportional to I, V equal to IR. So at a constant temperature. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. V is directly proportional to I, V equal to IR. So here, and one more thing we can say, that is materials required. What are the materials required? First one is first one is first one I am considering. Four cells 1.5 volts each. 1.5 volts each, and nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals of 0.5 meter length. Okay, here you can see four cells 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Okay, and we can take ammeter, and fourth one is voltmeter, ammeter and voltmeter. So next one, fifth one, ammeter and voltmeter. Next one, switch. Switch I am considering. Switch. And sixth one is connecting wires. Connecting wires. Connecting wires. Connecting wires. Connecting wires. So once again, Ohm's law is nothing but the potential difference across the ends of the given metallic conductor. The potential difference. So the potential difference across the ends of the given metallic conductor. Ends of the metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. Materials 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each, like that. How many are there? 4 cells. Nichrowire is an alloy of nickel, chromium, manganese and iron metals. So 0.5 meter. Ammeter, voltmeter, switch and connecting wires and connecting wires and connecting wires. Okay, so these are the materials required. These are the materials required. So these are the materials required. Now I am considering one more. I am considering one more. That is procedure. So procedure is you have to follow the process. So that is, first you have to connect one cell. First you have to connect one cell and note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells. Connect to two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4. Repeat the process for 3 and 4. Repeat the process for 3 and 4 and mention in the tabular form given below. So here you can see I'm taking the tabular form. I'm taking the tabular form like this. So serial number, number of cells, current and voltmeter V by I, that is nothing but R. V by I is nothing but R. 1, 2, 3, 4. Now next one is 4. So I'm considering one more, that is, we can take like this. So 4 cells we need, 4 cells you have to take, 4 cells you have to consider. Okay, check once. Marvel fan, thank you so much. And just you and me, thank you so much. Okay, done. So Ohm's law is nothing but it happens sometimes. The potential difference across the ends of the metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. Metals required. So what are the metals required? There are four cells. Four cells, 1.5 volts each, 1.5 volts each, 1.5 volts each, like that. Four cells I am taking. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. 0.5 meter. Ammeter, voltmeter, switch, connecting wires. And here you can consider here. So what is the process to do the activity? First you have to connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay, so mention in the tabular form given below. Mention in the tabular form given below. Okay, so you can check in the tabular. So you have to mention in the tabular form given below. Just you have to write like this. No need to mention any values in the tabular form. Just you can draw the empty table like that only. Okay, so now if you are going through it, if you draw the graph for VI, V on y-axis, I on x-axis, V on y-axis, I on x-axis, that is ohmic conduct. This is for ohmic conductors. Ohmic conductors. The substances which obey Ohm's law, those are called ohmic conductor. The substances which does not obey, those are non-ohmic conductors. So V on y-axis, I on x-axis. So here I am taking V on y-axis, I on x-axis. So this is for ohmic conductor, this is for non-ohmic conductors. So ohmic conductor means the substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey non-ohmic conductor. So the graph is for non-ohmic conductor. So this is for ohmic conductor. So this is about Ohm's law. Okay. So next we are going through it. Resistance. So now you can see resistors are connected in series combination. Resistors are connected in so Ohm's law over, right? Ohm's law over. Next resistance and resistivity will discuss. Resistance and resistivity. Factor depends on resistance. R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L by A. So R equal to rho into L by A. R equal to rho into L by A. So rho equal to RA by L. Rho equal to RA by L. So R is directly proportional to length of the conductor. R is directly proportional. R is inversely proportional to area of the cross section. So R equal to directly proportional to L by A. R equal to rho into L by A. Rho equal to RA by L. Rho equal to RA by L. So now I am considering here. So resistivity is equal to SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancelled, then resistivity SI unit is ohm meter. SI unit of resistivity 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 is ohm meter. Okay. So now once again, resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross. Resistance is directly proportional to L by A. Resistance is equal to rho into L by A. So rho equal to RA by L. So SI unit. If you are finding SI unit of okay. So here you can see resistivity is equal to SI unit of resistance is ohm. SI unit of area is square. SI unit of length is meter. Meter get cancelled. Meter get cancelled. Get resistivity is equal to ohm meter. 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 This is very, very important. So 2 marks question, very important. Make sure that you are preparing your learning. So you are practicing this one. So resistivity is equal to ohm meter. Resistivity is equal to ohm meter. Understood? So next one we are going to the one more topic, that is resistors are connected in series combination. 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 Series combination. So now you can see here, I am taking 3 resistors. 1, 2, 3. So ammeter. So battery, switch. So now you can observe here, resistors are connected in series combination R1, R2, R3, R1, R1, R2 and R3, R1, R2, R3. So all are connected in series combination. All are connected in series combination. All are connected in all are connected in series combination. Now you are considering potential difference is different in series combination. Vs equal to V1 plus V2 plus V3. So normally from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. So Vs equal to IRS. Vs equal to IRS equal to IR1 plus IR2 plus IR3, then we can take, so I we can take common, IRS we are taking common, I we can take common R1 plus R2 plus R3. So we can take we can cancel it, I get cancel. Then RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. So if resistors are connected in series combination, resistors are connected in series combination. Resistors are connected in series combination. So RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. So resistors are connected in series combination. Must you have to add all the resistance. So then you'll get resistance. Next one, we are going to the resistors are connected. We are going to the next topic. Resistors are connected in parallel combination. Resistors are connected in parallel combination. Resistors are connected in parallel combination. Now, resistors are connected in parallel combination. We'll discuss. Resistors are connected in parallel combination. Those are, so here so I1, I2, I3. So current is dividing into three parts. Current is dividing into three parts. So from in this resistors are connected in parallel combination concept. So potential difference is same across all the resistors. V1, V2, V3, that is Vs equal to V1 equal to V2 equal to V3. Now we can take, we can consider IP because current is different through R1 I1 through R2 I2 through R3 I3. So different current is flowing. That's why I1 plus I2 plus I3. So then we can take V IRS IR V by RP. From Ohm's law, V equal to IR, I equal to V by R, I equal to V by R. So that's why I'm taking V by R is equal to V by R1 plus V by R2 plus V by R3. So now you can take V, I'm taking common. V I'm taking common 1 by RP equal to RP. This is not RS, RP. So resistors are connected in this also parallel, right? It's not series. Parallel I'm taking. So parallel combination. So VP. So equivalent or a potential difference in parallel combination. VP equal to V1 equal to V2 equal to V3. So that is 1 by RP. Now 1 by R1 equal to V I'm taking common 1 by R1 plus 1 by R2 plus 1 by R3. So V will get cancelled. So we can cancel V value. We can cancel V value. So if you are cancelling V, 1 by RP equal to 1 by RP equal to 1 by RP equal to, so 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So these are the resistors are connected in parallel combination. If n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, Rp equal to R by n. Rp equal to R by n. So very important. 1 by Rp equal to n by R. Rp equal to R by n. Rp equal to R by n. So this is about resistors are connected in a parallel combination. So now we are going to one more. Last concept, that is heating effect of electric current. Okay. Heating effect of electric current. Heating effect of electric current. So heating effect of electric current is nothing but, so V equal to W by Q. V equal to W by Q. Potential difference equal to work done by charge. So double equal to VQ, double equal to VQ, P equal to W by T, that is nothing but VQ by T, that is nothing but V into Q by T. So Q by T is I, that is current. So that's enough. So P equal to V into Q by T is nothing but P into VI. So energy equal to P into T, P into T. So what are the energies given to the conductor? That will become in the form of heat Vi into T, that is nothing but IR into T, that is I square RT. I square RT. Heat produced in the conductor, heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So this is about heating effect of electric current. Applications of heating effect of electric current. So here we can take electrical oven, electrical cooker, electrical cooker, and we can also take room heaters. These are the examples for heating effect of electric current. Still it is there. And one more you can take, one more. Short circuit, the direct contact of live wire and neutral wire takes place, then heavy amount of current will be drawn from the mains. Okay, so fire will start occurring in the building. Then overloading high voltage appliances on at a time. High voltage appliances, high voltage appliances on at a time. High voltage appliances on at a time. Then heavy amount of current will be drawn from the mains. It may leads to the short circuit. That is about short circuit and overloading. Then live wire. So if you are taking live wire is 220. So live wire I am taking. Live wire is positive terminal. Live wire is positive terminal, red insulation. So neutral wire is, so it is 220 volts. Neutral wire is neutral. Neutral wire is neutral wire is neutral wire is so negative terminal. So 0 volts. Earth wire is you can take so green color insulation. This is black color. Okay, green color. Understood? Live wire is positive terminal. Live wire is positive terminal. Live wire is positive terminal, 220 potential difference. Neutral wire is negative terminal, 0 potential, black in color. Here is red color, here is black in color. So earth wire is green color. So the potential difference between live wire and zero wire is 220. The potential difference between live wire and green earth wire is 220. The potential difference between neutral wire and earth wire is 0. So this is about electric current. So we discussed all the points. So if you Okay, so thank you so much for joining and attending and interacting with me. So thank you so much. Those who went for super chat, thank you so much once again. So that's enough. So we'll see you in the next class. Thank you.